So I'm not sure how far we got, but we're going to go ahead and start with this. Let's say we wanted to find the equation of a tangent line to this equation, y equals 3x squared minus 2x add x equals negative 1. First of all, you should look at that and you should have an idea that that's a parabola. So we're trying to find the equation of a tangent line to a parabola. The equation of a tangent line is going to be a line, so we're going to want to put it in slope-intercept form. And my first step is when I see tangent line to understand that I really want its derivative. So I know that y prime would then be 6x minus 2. If I use the power rule. Then I want to find out what the ordered pair is, so if I plug negative 1 into the function, I get 3 times negative 1 squared plus 2, which would be 5. And then I want to find the slope of the tangent line, which is the y value if I plug in the x value for the derivative. So y prime of negative 1 is negative 6 minus 2, or negative 8. So this negative 8 is my slope. And then I'm going to put this together into point slope form. Y minus 5 is equal to negative 8 times x minus a negative 1, or y is equal to negative 8. That'd be minus 8 plus 5, 8x and minus 3. Just double checking. Yep. And then I'm going to come back and I'm actually going to look at a graph. So I'm going to pause this for a second. Kind of set this up on a graph form, but I do want to graph the line that I came up with. Just to try to check it out. So I came up with the line y equals negative 8x minus 3. So let's graph that. Oops, sorry. Let's see. Tab. And I'm going to go negative 8x minus 3. And it's looking pretty good. Now, I'm going to pause this one more second. There's multiple ways you can start to do this in this graph. One thing I can do is I can say analyze graph dy dx and click on the blue graph and then move the point to where we want it to be. We want it to be at negative 5. So if I put it right here at negative 5, it says negative 8. That just tells me that the slope of, oops, I'm moving that out of the way. Hang on, let me undo that. The slope of the tangent line is negative 8. So that just kind of confirms what we have here. There's another feature you can do, but this is less useful because this might be just a little bit confusing. Actually, I'm going to hold off on that. We can graph the derivative, but I don't want you to see yet what derivatives look like in a graph. It might be a little confusing. Okay, forgive the pausing a lot. I just want to make sure I'm not wasting your time. Okay, another thing we can do is we can look at horizontal tangent lines. A very common type of question is determine the points where a graph has a horizontal tangent line. So let me just take like a graph like f of. Here's a big one. So we want to find f prime of x and say that that's okay. So we're going to get really fast at this. 12x cubed plus 48x squared minus 108x minus 432. And then the derivative of 24 is 0. And we're going to set this equal to 0. Now, it turns out, coincidentally, that everything is divisible by 12. So I'm just going to divide both sides by 12. X cubed plus 4x squared minus 9x minus, that would be 672, 6 is equal to 0. So then I'm going to have to try to factor this. Well, this is a factor by grouping x squared and x plus 4 minus 9 and x plus 4. X plus 4, x squared minus 9 equals 0. And we know that the x values would be negative 4 and plus or minus 3. Now it says determine the points. Okay. I'm just going to set this up because I don't want to actually, but if you, and the problems you get are going to be easier, but if we really wanted to effectively plug in and get the points, I would probably synthetically divide this and make it 316, negative 54, negative 432, 24, and just do a little bit of old school pre-calc synthetic division where I bring down the 3, multiply, and add. So it's 4 multiply negative 16 and add. That'd be negative 70. Multiply, that'd be 280 and add. Now I'm going to do this right here because I don't want to mess this up and have you guys all laugh at me. That'd be negative 152, and then multiply by 4, that'd be 304, 608, 608 and adds, that'd be 632. So I know that one of my ordered pairs would be negative 4, 632, and I would just leave it to you guys to figure out what the negative 3, 1 is and what the 3, 1 is. Really, you can just do it like that. And if you remember how to synthetically divide, just use that single table strategy to get it. Again, yours will be easier, promise. Okay, number 3. This is actually going to be like number 66 from your book. I'm going to do this because I just want a good example, and I'm running out of time here on a Sunday to kind of create these. These are problems that were not in the regular part of the class, or regular CalcA-AP. So congratulations, you're still an honors AP course. Those are the information. The question is to find K such that the line is tangent to the graph of the function. This can be tricky. It makes sense to me, and this is kind of one of those where when you realize what you have to do, there's sort of this moment of like, really? What you need to have, like for this line y to be tangent to f of x, is y actually has to intersect f of x, because that intersection point should be the tangent point. Oops, it's actually really hard to freehand that. So you actually have that they intersect, so you get to set them equal to each other. Negative 6x plus 1 equals k minus x squared. So not only do they intersect each other, but their derivatives should be the same as well. Because for the line to be tangent, that means that the slope of this line, which is negative 6, should be equal to the slope of this line at that point. And the slope of this line at that point is negative 2x. Remember, the derivative of k is a constant, so k has a derivative of 0. So this isn't the worst system of equations to solve. We solve the second one and get x is equal to 3. I plug it into the first one and I get negative 16 plus 1 is equal to k minus 9, or negative 17 is equal to k minus 9, or 8 is equal to k, no, lo siento guys, my brain is hurting. That would definitely be a negative 8. I'm back. Just go with me on it. Okay, so we get that k is equal to negative 8. And then that's it. We've answered the question. We found k. Finally, physics people, you're going to love this, and non-physics people, I am so sorry. But back in physics, you learned this equation, s is equal to 1/2 at squared plus v sub 0 t plus s sub 0, where s is position, s sub 0 is initial position. I'm just doing this from memory. Thank you, Buff Jesuit Physics. V sub 0 is initial velocity. T is time. And A is acceleration. And typically the units have to match. So if s is position in meters, s sub 0 is position in meters, v is in meters per second, t is in second, and acceleration is in meters per second, or meters per second squared. I'm going to kind of erase the first part of this, and we're going to say s of t, because I want you to know that your independent variable and your dependent variables are t and s respectively. So you're going to have some problems at the end of your assignment. This is why I wanted you to have some preparation so you can do this with each other that do this. Now, I'm going to qualify this and say that you've seen this before where your book tends to use feet and not meters. I know that hurts me too. So this whole meters thing, just kind of get used to the feet thing, and sorry, let go of negative 9.8 for at least a few problems. It gets back to that. And it cheats and it gives you like the acceleration due to gravity by feet is negative 32 feet per second squared, and the acceleration due to meters is negative 9.8 meters per second squared. You don't have to know any of those. It actually gives you those in the equations. What you do have to know how to do is you have to know how to take the derivative of this, regardless of what form it gives you. So for instance, it might give you the form s of t is equal to negative 16 at squared plus v sub 0 t plus s sub 0. Okay, all it did, oh sorry, negative 16 t squared, not negative 16 at squared, it just substituted. All it did was substitute a value for a. Now, the derivative of this, s prime of t, the derivative of position is velocity. So this is velocity. And so that would become negative 32t plus, we're deriving with respect to t, so this right here is sort of like deriving 8x. It would just be 8, but in this case it would be v sub 0. So I get v sub 0. And then s sub 0 is just a constant, so that drops out. That doesn't play a role into it. So we get these two equations. The first one is position, and the second one is velocity. Likewise, if s of t was negative 4.9 t squared plus v sub 0 t plus s sub 0, that's the same thing but given in meters per second. And if I want to derive that, I would say v of t, the derivative is 9.8 t plus v sub 0. So knowing how to take those derivatives is key to getting two versions of the equation that will actually help you answer some other questions. Now, I don't want to spend too much time on this, but let's do one example. I'm going to look at example 10 in your book. It says, I'm going to say 10, and this is, if you want to follow along, because it has a neat, little picture, page 114. I'll actually pause. Let me pause and put that picture in here. This is the figure, and it's kind of good to note. Let me write the problem down. It says at t equals 0, at time equals 0, a diver jumps from a platform that is 32 feet above the water, and his position, or her position, s of t, equals negative 16 t squared plus 16t plus 32, where s is in feet and t is in seconds. Okay, question wants to know, 1, when does diver hit the water? And 2, it wants to know diver's velocity at impact. Now, when we're talking about vertical, typically with anything, that direction is positive and this direction is negative. So just keep that in mind. We're going to try to keep our signs straight with that. Velocity is positive when an object is rising and negative when an object is falling. And it says, notice that the diver moves upward for the first half second because the velocity is positive for 0 to t to 1/2. And then when the velocity is 0, the diver has reached the maximum height of the dive. Now, how do we know that? Well, here's the thing. To find the time when the diver hits the water, we're going to say, when does the diver hit? We're going to say, I'm trying to give it a little bit of organization. I'm going to delete this for a second, and I'll move it back. I'll write it back in a second. When does diver hit the water? Diver hits the water right there at s equals 0. So at s equals 0, I'm going to go 0 is equal to negative 16 t squared plus 16t plus 32. And that's just a factoring problem. If I pull out a negative 16, I get t squared. Actually, I'm just going to divide it out of both sides. I get t squared minus t minus 2, or t minus 2, t plus 1. We're talking positive t, so at t equals 0. T equals 2 seconds. So that's when the diver hits. The velocity, though, and that was question B, the velocity at impact. This equation says nothing about velocity, so I have to know that I'm going to take the derivative s prime of t. and that's going to be equal to negative 32t plus 16. And if I can write s prime of t, I can also write v of t, negative 32t plus 16. Well, hopefully you see that you just plug in 2 seconds. So negative 32 times 2 plus 16 is negative 48, and that would be feet per second. And that makes sense. It's negative. He's going down. He's accelerating, so he's getting faster. Okay, that's it.